So let's do like a 1 minute intro, and then we'll do 40 minutes of the interview, and then I'll give you feedback. So can you tell me a little bit about yourself?
Yeah, sure. So I'm a software engineer with close to 4 years of experience. I primarily work on the platform and product end. And yeah, I have experience with LLM frameworks, and that's the current application that I'm working on also. And I'm currently interviewing for like different companies, but I'm primarily prepping for Meta
Okay.
um, in February.
Okay, cool. So let me paste the first problem here, and right now it's 6:05 my time, so we'll go 40 minutes. And you kind of have to pace yourself, so like take as long as you need. But remember, we have two problems. So the first problem is this. And it's a pretty common one, so let me know if you've seen it or you don't want to do it. We can do another one if that's the case.
Sure. Given a binary tree, find the LCA. Okay. um, Got it. And the binary tree has, I'm assuming, like a left and right pointer, right?
Yes. So binary tree has left and right pointer. Yes.
Got it. And let me see. Okay, yeah. So this is how I'm thinking of solving it. So we have nodes P and Q, which are both nodes in a binary tree.
Mm-hmm.
So let me start off with an example, maybe.
Sure.
So we have 5, 4. Okay. Let's say this is our binary tree, and the nodes we are given is P equal to 7 and Q equal to, um, let's say, 6. So in this example, the lowest common ancestor would be 4.
Mm-hmm.
So I would first start off with finding a path uh, from the root for both P and Q.
Mm-hmm.
So I would do like a DFS search, and then I would calculate the path. So I would have 7, 4, and 5 as the path,
Mm-hmm.
and a similar thing for Q also. So that would be 6, 4, and 5. I would store this in a stack. Okay. Uh, Next, what I'm gonna do is start popping both the stacks simultaneously until I find an element where it does not match P and Q, and then um, the last emitted element would be our least common ancestor.
Got it. Okay. Yeah, I think that makes sense. So basically, you're saying this path is the root will be on the right side of the stack.
Yes.
So you're essentially guaranteed to get okay. Okay, that seems fine to me. So you don't have to code this other one, but can you think of like another way to do it? We can go with your approach to code, but can you think of like, without doing a DFS of the path, can you think of another way we could have done it like in like one pass maybe or something? And you're not
Mm.
gonna have to code it. I'm curious if you can think of anything else.
Mm-hmm. Let me quickly think. Um, so if there was a pointer to the parent, then I would have like a different approach.
Hmm.
Um,
But there's not because it's a tree.
that's yeah, yeah. Um, just thinking for something better.
Mm. Okay, I don't want to take too long, so I think your approach is pretty solid, so we can just go with that. So before you start coding, so what's the time and space complexity of like what you're doing?
Yeah, so it would be O of n for the DFS, where n is the number of nodes.
Hmm.
Um, and the space complexity, again, first case would be O of n.
Okay, yeah, sounds good. Okay, I think you can start coding, and I'm gonna just give you a class to make it easier. So I'll just
Okay.
paste a tree, pretend you have this thing that you can just use.
Mhm.
And we're not going to run your code so if there's like errors or something because you don't have like the tree node, it's totally fine as long as it makes sense.
Okay. Okay. Think I've implemented an outline. I can go over the code maybe with an example.
Sure.
Okay. So with the example I've given here, so we're starting with um, uh, root equal to 5, p equal to 7, and q equal to 6. So we are initializing the stack, and then we are calling DFS on both P and Q in order to form the path to the root.
Mm-hmm.
So let's see how that works. So initially, node is 5, P is 7, and stack is empty. So we do some checks for the end condition. The node is not null, and the node is also not equal to P.
Mm-hmm.
Um, so now we call DFS of the um, left. So that's node equal to 4, and it is 7, and stack is again empty, which again calls node equal to 7, P is 7, stack is empty. Okay, now when node is 7, P is 7, we come to this case where node is equal to P. So we are adding it onto the stack and returning true. So this goes back to node 4, P7, and stack now has 7 in it. So the first condition has returned true. So you here again the node 4 can be pushed onto the stack, and this returns true, which goes back to this example where again the stack has 7, 4, and because the if condition has true, we will push it to the stack and return it.
Mm-hmm.
And yeah, so that's the path constructed for P. And for Q, let's see, Q is 6. So let me
So it would
recreate.
be 745, right? Actually, for the
Yeah,
stack.
745. So this would, when this returns, the next call, it would be 745.
Okay, got it. Yeah.
Yeah.
So you can just draw the two stacks to save us some time, and then go from there.
Okay. So the second stack would be 6, 4, 5.
Mm-hmm.
And after that, I'm keeping track of a previous tree node in order to find the LCA.
Mm-hmm.
Now, in the while loop, I check if either of these stacks are empty, and the idea is to keep popping from both stacks until the top value is not equal. And so when we check, okay, let me just put this here. Yeah, so initially 5 comma 5 is checked, it goes into the while loop and it is popped. Similarly 4 comma 4 is checked, goes inside the while loop and it is popped. And next is 7 and 6. We see that it's not the same. So the while loop ends, and the previously matched node was stored inside previous. So that's being returned.
Yep. Yeah, I think that makes sense.
Mhm.
Um, And yeah, so let me ask you. You didn't ask, like, or I can ask you. Can we ever not have a lowest common ancestor? Is that possible?
So if the tree is empty,
Mm-hmm.
um, that yeah, then so essentially, like if P and Q, if they are not part of the tree, then
Mm-hmm.
that could be a scenario where there is no lowest common ancestor.
Mm-hmm.
Um, yeah, again, like if the tree is empty, um, that's also another case. But yeah, if
Okay.
basically P and Q need not be part of the tree, so that's like an edge case.
Okay. Got it. Okay. Sounds good. Okay, we can move on to the second one.
Hmm.
So let me paste it here. Once again, if you've done it, just let me know. I can give you something else. And here's like an example.
Given an array of points representing a point in the xy plane and an integer k, return the k closest points to the origin, the distance between 2 points on the xy plane. Okay. So essentially, I'm given a set of points and I need to find the k closest points to the origin, right?
Mm-hmm.
Not, okay. And
Yeah, not
yeah.
each other or something.
Mhm. I may return the answer in any order. Answer is guaranteed to be unique except for the order that is it. Okay. So my initial thought process is that okay, so definitely need to find um points. Okay. Okay, so thinking that um I can iterate the points array and find the distance of each point to the origin.
Mm-hmm.
And I need to find the I also need to return the k closest points to the origin. Let me think about it. Yeah. So I am thinking that I can have a max heap. So as I find so I um, find distance between point I and origin,
Mm-hmm.
then I will add it to a max heap. Um, so basically, when I add it to a max heap, the maximum, so I'll be adding the distance to the max heap. So the maximum value would be at the basically at the root. And I also check the size of my heap. So if size of heap um, greater than k, then I remove the first element,
Okay.
and I'll continue doing this for all of the points. And at the end, I will have k elements in the or like k. Yeah, I'll have a k. elements in my heap, which will be closest to the origin. And I guess I need to return the points, right?
Mm-hmm.
In my y. So in my heap, I can store it as I guess like a maybe like um, something like this. So I'll have distance. I can have x and I can have y. So I'll store all three information in my heap.
Okay.
Yeah. So at the end, I can just pop all of the elements, all of the remaining elements of the heap, add it to a list, and return it.
Yep, makes sense. And then what would be the time complexity for this one?
Right. So inserting into a heap of size k would be O of log k, and we have n elements. So let me think. So this would be n. This would be log k. These are n elements, and this check is constant because we're removing the first element. Um, and then again, to reconstruct the result, it would be O of k.
Mm-hmm.
So it would be n log k um,
Mm-hmm.
plus plus k, I guess.
Yep. Can you, I guess, simplify that?
Yeah. So if k is very small, we can just ignore it, and then n log k would um,
So basically, like, even if k isn't very small, let's say n is like a million and k is like a million minus one,
mhm.
what would be the time complexity?
um, I feel like I would uh, add k into it, like of n log k plus k.
So because n is essentially, I mean, you didn't ask, but because n is always like bigger or equal, like,
Mhm.
and assuming log is bigger than one, it'll be like a number that's bigger than k times a number that's bigger than one. So the left side is always bigger than the right. So you can just cancel out the right.
Okay, makes sense.
Okay. And then what's the space?
Space would be O of k.
Okay. Uh, yeah, I think this is good. So we can code.
Okay.
And you can just make a function below the problem. Like, don't code up there. Just make a function below
Sure,
the
sure.
thing, and you don't need to make it static or whatever. We're not running it anyway, so you can just make a function, and you don't need a main or anything.
Mhm.
So you don't need to import if you don't want to either. We're not running it, so.
Okay, okay. Um, no, I was thinking of
Oh, making some like struct or whatever.
Yeah, yeah,
Yeah, you can do that if you need. You can just make it above and we'll pretend it's in the class. Or you can make a class, up to you.
yeah. So, okay.
And we have about 11 minutes left, just to give you a heads up.
Okay. Gratitude. Okay. Okay, so it's gonna be Um, okay, I think this should work. So the function takes a list of points and an integer k. I've created a max heap using a priority queue. So, so I'm iterating through the points array and calculating the distance. I haven't done the square root because I thought like it would maybe like save computation if I'm not doing it for all of the points. And I'm calculating the distance and I'm inserting it into the queue. After that, I'm checking if queue size greater than k. If it is greater than k, then I am removing the top element, and this continues for all of the elements in points array. Once that is done, I will be computing the like the result array. So I'm initializing it to q dot size. Like we might not always have k points. So I'm looping through the queue. I'm removing the element, getting the x and y, and storing it into the result array, and then returning it.
Okay. Yeah, I think this is good. Honestly, for this one, we probably don't need to do a dry run. It's pretty straightforward.
Hmm.
Um, okay. All right. Let's do feedback then.
Okay.
Okay. Yeah. So, how do you think you did?
Um, I think both the questions were pretty, like, I felt straightforward.
Hmm.
So I was able to come up with a solution for it.
Hmm.
Um, I did think like you hinted towards me not asking questions for the first one. So I think that might be something that I need to work on.
Hmm.
Apart from that, um, yeah, I think that's it from me.
Okay. Yeah. So, I will say you're kind of right. These are kind of straightforward questions. Because you said you're preparing for tech screen, I just picked some easier ones. I feel like that's pretty fair.
Mhm.
On the onsite, they might ask you harder ones. Maybe you can like schedule another one for like harder questions. But granted, like they're not like even though they're common and easy and stuff, like you still did very very well. I feel like so basically you restated the problems. I think one of the things you didn't do, yeah, like I said, you didn't really ask about constraints or edge cases or things like this isn't leak code, so like I know in leak code maybe you did this problem and it says like P and Q or like in here, but that might not necessarily be the case. So don't try to remember like, oh, I did this on leak code and what were the constraints? Be like, like do these things actually exist? Like what happens if the tree is empty? What happens if P and Q aren't in there? What happens if one is in there? All that stuff. And then go from there. And it takes like 30 seconds to ask that stuff and it's like 3 points. And it's gonna hurt you a lot if like they expected, you to account for these things and you just never asked. Or they had to like point it out.
Got it.
So I think these are like very easy things that you can just get free points on.
Hmm.
Um, let's see. Yeah, so you came up with one approach. Like I said, this was like a little bit easier of a problem, so I tried to probe another. Another approach you could have done was you could have done like basically a DFS, and then you can just count how many points have you seen like at every node. Kind of like you return true, you could just return like a number, and then at whatever node you return like that you've seen 2 points, that's like your answer. That's like another way of doing this problem, but your approach is totally fine. Um, yeah, I don't think I've seen your approach, but like just thinking about it, it like makes perfect sense. And you explained it was very clear. I didn't have any questions. And I think your coding was really good. Like very clear. Pretty much no mistakes. Once again, easier problem, but still like, you know, uh, you knew very well what you were doing. I think one of the big things about like picking Java, like I interviewed in Java, you really have to be fast because it's pretty verbose. So
Hmm.
making mistakes kind of hurts. But yeah, like I think that part was good. I think the part I would say you did the worst is
Hmm.
so the whole time you coded, you basically didn't say a word. I would
Right, right.
definitely improve in that area, like say what you're doing, because the problem might be more complicated. And something that might come up is like you say like I'm gonna do X and then you do Y and you don't even notice, and then the
Mhm.
interviewer can like point that out to you. But if you don't say what you're doing, it's harder for them to know what you're doing, and it's harder for them to like fix what you're doing, and they probably won't even want to because you're not saying anything. So I think that would be like the biggest thing is like as you're coding, say like, oh yeah, so I'm making like these two stacks, I'm doing like a DFS, blah blah blah, stuff like that. It is kind of hard to talk and code. Maybe I would like record yourself like doing the problem and like talking and stuff.
Mhm.
But that would help a lot. And then, but you did explain it like very well. Like afterwards, you're like, okay, I'm done now. Here's exactly what it did, and it's again super clear. And you did a dry run, which was good, super clear as well. I would say for the dry run, maybe figure out a way to do it quicker. Maybe just have like a stack and then like chain, like maybe have like a pointer and just move it or something. Because writing line
Mhm.
by line, if it's like 30 lines and you're in a time crunch, is not the best.
Right.
So definitely try to speed that up.
Mhm.
And that's why I kind of said like for the second one, just write it out because like
Mhm.
there's like a time crunch. I think that's one of the biggest things for like the meta one in particular is you only have 40 minutes and the time goes really fast even if you know the problem. Yeah, so that was good. And then for the second one, you also restated the problem. You didn't ask about the edge cases, but your code kind of handled it. So if you know your solution's going to handle like the edge case that you don't need to ask about, like you
Mhm.
basically didn't ask like what if k is bigger than n or something. And I
Mhm.
wrote down you didn't ask, but then your solution kind of like took care of it, so it was fine. But you can also just ask because
Okay.
once again, it's like 3 points. Like I would say, don't ask questions that have like no meaning at all in
Mhm.
your solution. Just to ask. But if it's like relevant at all, then just ask.
Makes sense. Yeah.
Yeah, and then you came up with a heap, which is optimal for this one. But once again, like easier problem, so it's like expected. Like I'd say if you did like a sort, I would just push you towards can we do something else.
Mhm.
Um, and then yeah, your code was really good. Your explanation was really good. I would say in Java, personal preference, but I usually just use, I don't know if you're familiar with like a record. I use a record a lot just because then you don't have to make a class, especially if you have to make
Mhm.
like if you have to make a custom class and it needs to be in like a hash map and a set or something, then you need
Mhm.
to make it like, you need to make like an equals and a hash code and all this stuff, and that just takes a bunch of
Mhm.
time. So using a record just gives you all of that in like one line. Um, so
I was not aware of it, but I'll check it out.
Yeah, so record is basically like a Java tuple. Like it'll make this thing in like one
Mhm.
line.
Okay. Okay. Got
Okay.
it.
And then let's see. Yeah, your code was really good. You had like a good comparator. You did that correctly. You also I wrote down like I don't think your code's gonna work with a distance if you don't do the square root. But then I realized like, oh, you're actually just doing the points and the square root doesn't matter because like the bigger number will just win anyway. So this was like
Mhm.
a good optimization, and so I kind of took this the it doesn't work without square root and got rid of it. I think it works fine. Um, and then yeah, basically it's like once again everything's super clean, super easy to follow, super easy to understand. Same thing though, you didn't really say anything you were doing for like whatever 5-10 minutes while you were coding, but then you explained everything. So I would just kind of explain as you go instead of at the very end. I feel like is like the biggest thing.
Got it. Got it. Yeah, makes sense.
Yeah, so I would say for like I think the four categories that I feel like are important. Obviously, I don't have like the meta rubric, and even if I did, I couldn't share it with you. But like so, there's like problem solving, which is like you get a problem, how fast can you come up with a solution? I felt like that was like a strong hire. I think your coding was also very good. Like you basically had no bugs, um, which is also like a strong hire. And then your algorithm knowledge was quite good. So I'd say it's like a strong hire there. And then the bad one was like communication. I think that one is like a almost like a lean no hire, weak hire, like that type of thing. Because like you just had time periods of like 10 minutes where you didn't say a word. And nowadays also with like the AI cheating stuff, like I would just try to say stuff so people don't assume you're
Yeah.
cheating.
Yeah. Mhm.
Um, but all these things, the nice thing is like all these things that you did like can improve upon, they're like very easy. It's like 3 points, right? Just like talk more, ask a few questions, and like you're fine.
Yep. I was also wondering, like during the interview, so I felt like I knew what like a reasonably good solution would be.
Hmm.
So I didn't really like touch upon the more trivial solutions. How important is that during interviews?
So for meta in particular, if you want to say something like honestly, what I did, I think for my stuff. is so let's say there's like three solutions, right? Like for example, for the second one, like let's say you can be like, oh, I can do a sort, I can do a heap, and I can do whatever, something else. I would
Mm-hmm.
honestly just say in like one sentence, I can do a sort, but a heap is better. You just don't have time to talk about anything other than the optimal.
Mm-hmm.
So I would just, yeah, just go straight for the optimal, and then mention the other one in like a sentence or two, just so people know that you know it. Um,
Yep, yep.
and then get and if what you think is optimal, they'll say it's fine. If they don't like it, then they'll like push you towards something better. But you just don't have time to be like, oh, let me do the brute force or whatever. You just won't finish. So that's what I'd recommend.
Yep,
Uh,
makes sense.
yep. Yeah. So yeah, if you want to schedule another one that's like a little bit harder down the road, totally fine. But yeah, I think you did really well. I don't know how long you've been like studying and stuff, but yeah, I think this is really good. So yeah.
Yeah, yeah. I think I have been working on lead code for a while.
Uh
So
huh.
I feel like I still struggle with the more medium to hard problems.
Hmm.
But yeah, I think it's helped me with my coding speed at least.
Yeah, so we can definitely do like if you're interested in the future, do like a harder one that's like harder problems and more time crunch and stuff.
Yeah.
But as far as I've seen for now, this is quite good, and I would expect the tech screen to be around this level.
Mm-hmm.
Like there is the one thing I will say is like from talking to people and from doing questions myself, I can't say what I got asked, but there is definitely not everyone gets asked the same thing. Like you can just get asked really hard stuff and kind of like ruin your interview. You know, like it's super random. So I think what they try to do is like if every question was like this, every single interview you had, they'd probably say it was too easy and do like a follow up round or something. So
Mm-hmm.
you are going to get like some stuff harder, but it's totally random like how hard your stuff is. And I've seen people get asked some pretty ridiculous stuff. So and that's like kind of beyond your control. You know, you can do what you can do. Like if you get asked some super hard question in 20 minutes, like sucks, I guess. It's hard to prepare for that. So and they do ask, I think they do ask stuff that's like not on their meta tagged. They also ask a lot of like variants and stuff. I think there's like videos people post on that. So I'm generally not a huge fan of like memorizing solutions. I'm a bigger fan of just like learning the concepts, learning them well, and then like you can kind of come up with the solutions. Like I don't know if you've seen these problems, but even if you haven't, if you've done enough problems, like you can just come up with these like on the fly very
Mm-hmm.
quickly. So yeah. But yeah, I think that is everything. So yeah, let me know how it goes, and if you want to schedule another one, you can feel free to do that with the same link.
Yeah, definitely. Thank you so much.
Cool. See ya.